Okay, in the previous video we created a library and then we used it with an executable. We linked against it with an executable. Now let's do both of those in one project. So instead of two different projects where example 7 made the library and example 8 linked against it, let's make a library and link against it in a single project. So they'll do that in example 9 here. And in this case, we have a source folder for our executable code. You could think of this like an example code or a tester. And we have the source directory that holds the sources for the library, and then we'll put our executable when we're ready to run it. We'll install that in the run directory. So our CMake list.txt, really similar to what we've had previously, but now we're adding both subdirectories, the library and the executable subdirectories. And if we go into the library directory here, then we're reusing this hello and we're going to install it. We're changing the name to hello shared 9 just to distinguish it from the one that we made in example 4. And so we're going to install this with the configuration so that we can make use of it with the find package if that's desired. So if you look at the CMake lists.txt, it parallels kind of what we did with the example 4. We add the library, give it a name, hello shared 9, and it's a shared library. And then we give it its sources and its header files. And then we install it. Again, we're going to use the GNU install dirs. These can be removed. They're included for generality and in case you want to change them. But these are the default values anyway. So we install the library here, hello shared 9, and then we're telling it also we're going to export this, which is going to make it so that we can use it with this configuration. And that'll be used in the next command there. And when we install, we both do the library and also the header files. And so we put those in this CMake install include dir, which will default to include, which will be tacked on to the end of the CMake install prefix, which we define to be in this top level user. Okay, so then we have the second install command, and this is going to actually do the exporting of this CMake. So we do export this export variable that we made, and then we have, or this name rather, then we have this file that we're exporting is hello shared 9 exp.cmake, and this will be the CMake generated, has all the commands that are needed to find paths and load the correct objects. We give it a namespace, hello shared 9 : and we tell it the destination where we want to put it. So this will be in that install prefix, and then /lib/cmake /hello shared 9, and then you'll have this file. Okay, same sort of thing that we did in example 4. And then we also install this file hello shared 9 config.cmake, and we tell it where to put it. And that file is really simple as before. It doesn't have any dependencies, so it literally just includes the CMake generated file there. And both of those will be installed as part of the process. So then let's go up and look at the executable. If we look at the executable is going to use this library hello that we're building in the source library up here. It's going to use the library that we just built, and it's also going to use this other library that we built in example 7 that's called beat it. So we're giving an example of a CMake project which creates a library, an executable that links against that local library, and then also links against a previously installed library from a different project. Okay, so let's go back into the executable. Oh, I'm there already. Okay, CMake list.txt. So just like before, when we want to connect against shared libraries, we need to set this. We need to set these variables: CMake install rpath use link path true, and that's so that our executable can find the external library. And then we also need to set this other variable, set CMake install rpath to be CMake install prefix /lib, so that it can find the so that the executable can find the local library. So these are the two commands that we need. And the reason for this is that when you do the build, it will install the executable and build, and all the paths will be there, which is convenient for things like development and testing. But when we go to install the library, it won't pick up paths for local to this project libraries that we're linking against. So that's what this first command does. And then the second command will also pick up and add the path, that lc underscore rpath that was part of the executable that we saw in the previous video with the O tool. It'll pick that up for the external library, in this case, to beat it. And those commands need to be set before we add this executable. So then we add the executable, tell it its source file, and in this case we're doing that all in one command instead of in the add executable and then the separate command that adds the sources. And then we're going to add in that external library. And because it was done without configuration, just like example 8, we do find library beat it shared and stored in this variable beat it, and then we find the path for the header file and store it in beat it inc, and then we include the directories for that beat it project right here, and we include the directories for our current project, which is just going to be in this source dir, our current, in our project source with the source lib. So we have the locations of the libraries, both the internal library and the external library, and then we're going to link the libraries into this project. So we have we have two of them. We have the local library, hello shared 9, and we have the external library that we built earlier in example 7 called beat it. So we've linked against both of those libraries, and just like before, because this is local, it's going to find all the paths, and because this one, when we build this external one, we're telling it where the locations of those, where those locations are. So then we come down here to install it, give it the destination, and we're done. Okay, so let's give that a try. Make a build directory, cd build, cmake make install. Come up here to run and use libs, and it runs both of those. And if we look again at that code, we're creating a hello object that calls hi there and a beat it object that calls hi there, and the one outputs hi there and the other outputs beat it, and it works just fine. Again, to look at that O tool, we can do O tool -L and then the executable, and we can see that in fact it's looking for this library beat it shared.dylib, and it's also looking for the hello shared 9.dylib, and we have this lcr path that points these rpath commands that allows these @rpath statements to resolve to the place where both example 7, which has the beat it library, and also the example 9, which has the hello, is there. And we might need to do a little work to clean this up. So that works pretty well. Just to emphasize again this issue with the those set commands. The set CMake install, here, let's go up and look at that. Go back up to the executable, look at the CMake list.txt. The set CMake install rpath, set CMake install, anyway, that top command there, set CMake install rpath command, that's needed for the internal library, in this case hello shared 9, and the other one is needed for the external library. There's some nice description of how those work. It can be a little bit tricky to understand, and I've included in the README for example 9 a link to a very nice site that gives a really detailed and clear description of how that works. Look especially at the paragraph about halfway down that starts with CMake install rpath use link path. Anyway, you can go have a look at that. In short, the rpath treatment is different for build and install steps. By default, build will have rpath for the local and external libraries, but the install will have neither. The first command that's in this source at the top there, or the CMake list at the top there, includes the local library in the rpath because we're explicitly adding it, and the second will include any linked rpaths except for those in the build tree, that is the local library. So that can be a little bit confusing. I found it quite confusing, and I was very grateful that that link that's in the README could help clear that up a little bit. And of course you can use the otool-l if you're on a Mac system to see exactly how those are being set, and if they're being set correctly. Okay, and that's all for this video.